IUPAC Nomenclature of Organic Compounds, Lecture Series L-4, Naming of Aliphatic Saturated Hydrocarbons, Part 2, Writing Name of Alkanes after numbering. To write IUPAC name of alkane, first complete numbering of parent chain, then follow the rules as given below. Rule 1. If there are no substituents, then write the root word followed by primary suffix "ane". Consider this example. There are 5 carbons in parent chain. Root word pent and primary suffix "ane". IUPAC name is pentane. In this example, the parent chain is 7 carbon chain, and here there are no substituent for 7 carbons. Root word pent and primary suffix "ane". It is heptane. Rule 2. If there is a substituent, then its name is written as a prefix before the root word. Location of the substituent is represented by writing initially the locant number separated from its prefix by hyphen. In example 1, the parent chain has 4 carbons with a substituent methyl at locant 2. Therefore, its IUPAC name becomes 2-methyl as a prefix, but the root word, ane as a primary suffix, 2-methyl butane. In the second example, the parent chain has 5 carbons with ethyl substituent. Its IUPAC name therefore written as 3-ethyl pentane. Here, ethyl is a prefix. Its locant is identified as 3. The root word pent, ane, 3-ethyl pentane. Rule 3. If there are more than one substituent, then their names are written as prefixes in the order as per alphabetical order before the root word. While writing alphabetical order, the secondary S, the tertiary T is not used to write alphabetical order or selection of the prefixes in alphabetical order. Consider this example. The parent chain has total 7 carbons. Methyl has locant number 5 and ethyl has locant number 3. Methyl starts with M and ethyl starts with E. Ethyl comes first in alphabetical order. Therefore, ethyl first be written followed by methyl. Here the locant number of ethyl is 3 and methyl is 5. Therefore, 3-ethyl 5-methyl. As there are 7 carbons, root word hept and primary suffix ane, IUPAC name becomes 3-ethyl 5-methyl heptane. In the second example, the continuous carbon chain has 9 carbon atoms and it is a parent chain. The numbering is done in this direction. Methyl group and isopropyl group are substituents at 2 and 6 respectively. So, 6 isopropyl, 2 methyl nonane. Here, I of the iso and M of the methyl are compared to arrange them in alphabetical order. Rule number 4. If same substituent is present more than once, then use di, tri, tetra to represent that substituent is present 2, 3, 4 times respectively. Write all locant numbers of that substituent by separating numbers by comma. Repeat the locant number if that carbon carries 2 same substituents. Di, tri, tetra cannot decide the alphabetical order unless if the name of the substituent has them. Let us see the example. The parent chain has 4 carbons with methyl substituents as at 2 and 3 locations. As methyl substituent is the name of the substituent present 2 times, use the dimethyl at what locations 2 and 3, therefore 2, 3 dimethyl 4 carbons but primary suffix ane butane. Its name becomes 2,3 dimethyl butane. In this example, the parent chain contains 5 carbons. Here 2 methyl groups and 1 ethyl group. Methyl groups are present on same carbon too. Therefore, this number must be repeated 2 times 2, 2 and methyl groups methyl as they are 2 times it is represented by di. Another substituent is ethyl. Now while writing in alphabetical order, here substituent name is methyl but it is not dimethyl. Here the di is just tells that the methyl groups are present 2 times. Therefore, the D of the di is not used to arrange the alphabetical order. Here ethyl and methyl are compared to write the alphabetical order. Ethyl comes first, then its name becomes 3-ethyl 2, 2 dimethyl pentane. The rule 5. If the complex organic substituent is present, then its name is written in brackets. A complex organic substituent is that whose name is written by the numbering within the substituents. Let us have some examples of complex organic substituents. This is called N-propyl or simply can be written propyl. It is not a complex substituent. Here, this is again a 3 carbon substituent, but this substituent is connected to the parent chain through this carbon atom. So, numbering is done 1, 2 and 3. This group by common name is called isopropyl, which is also accepted as IUPAC name, is not treated as a complex. But when numbering is done, this carbon through which it is connecting to the parent chain takes the locant number 2. So its IUPAC name can be written as there are 3 carbons prop, all are carbon-carbon single bonds in, as it is connected to the parent chain through the second carbon 2 and it is monovalent alkyl group YL. So propane 2YL. It is complex substituent. The other way of giving name to this substituent is let us give the number 1 to that carbon through which it is connected to the parent chain and then go to the longest carbon. Therefore, here the parent chain can have maximum 2 carbons and methyl left as a substituent on first carbon. So, it can be written as 1 methyl, as there are 2 carbons, it is ethyl. Then this is a complex substituent name. Now here it is another substituent which is called tertiary butyl, both common name as well as IUPAC name, but it is not treated as a complex. But if numbering is done by giving 1 to the carbon through which it is connected to the parent chain, then the longest chain one can get is a 2 carbon chain. Therefore, the 2 methyl groups are present on this first carbon. Its name becomes 1, 1 dimethyl ethyl, which is a complex substituent. Please note that here D is not telling that methyl ethyl substituent is present 2 times, but it is telling that it is the name of the substituent itself start with D. So this D must be considered in alphabetical order as it is part of the name of the substituent. The other way of the numbering is selection of the longest carbon chain, then giving lowest locant to that carbon through which it is connected to the parent chain. Therefore, on second carbon there is a methyl group. So 2-methyl prop, there are 3 carbons, prop, all are single bonds, ane, and it is connected through second carbon. So 2, it is being alkyl group YL, 2-methyl propane 2YL, which is a complex substituent. Let us see this example. Here parent chain has total 9 carbons. The numbering is done to give the lowest locant to this substituent, which is called tertiary butyl. Its IUPAC name becomes 5-tertiary butyl. It is on 5th locant, nonane, or it can also be written as 2-methyl propane 2YL, which is present on 5th carbon. As it is written as a complex substituent, it must be kept in a bracket. Therefore, IUPAC name can be written as 5-2-methyl propane 2YL nonane, or it can also be written as, this name is a preferred IUPAC name. We can also written as 1,1 dimethyl ethyl in a 5th position. So 1,1 dimethyl ethyl nonane. Very important note that methyl group can't be written as methanol. Ethyl group can't be called as ethanol, or in simple, when common name and IUPAC name are same, then use alkyl but not alkynyl. Rule 6. If the complex substituent is present 2 times, use bis, 3 times use tris. If the name of the complex substituent starts with the di, tri and tetra, then they must be included to compare alphabetical order of the prefixes. Consider this example. The parent chain has 9 carbons. Here there are 2 isopropyl groups at locants 5 and 6. There is one more substituent methyl group at locant number 3. Methyl versus isopropyl. Here di tells that isopropyl group is present 2 times, but it is not mean that the name of the substituent, this particular substituent, is diisopropyl. Therefore, D is not considered in comparing alphabetical order. Isopropyl group starts with I, methyl group starts with M. Isopropyl comes earlier in alphabetical order. Therefore, its IUPAC name becomes 5,6 diisopropyl 3-methyl nonane. Here, suppose if this is written as a complex substituent as propane 2YL, then we should write bis, because for a complex substituent its presence is indicated by using bis as it is 2 times. Now here comparing alphabetical order, methyl starts with M, propane 2YL starts with P. So methyl comes early in alphabetical order. Its IUPAC name becomes 3-methyl 5,6 bis propane 2YL nonane, which is preferred IUPAC name. And of course, one more IUPAC name can be written. The name of this substituent can be written as 1-methyl ethyl. It is present 2 times, bis at locants 5 and 6. Here in methyl M, in methyl ethyl M. So if the both compare in alphabetical order, methyl comes earlier than methyl ethyl. Its IUPAC name becomes 3-methyl 5,6 bis 1-methyl ethyl nonane. Now consider one complex example. The parent chain contains the 9 carbons with 2 substituents ethyl and tertiary butyl. As earlier said, T can't don't be we don't consider T in writing alphabetical order of the prefixes. Now B of tertiary butyl, E of ethyl groups are compared. Then tertiary butyl comes earlier in alphanumeric order. Therefore, its IUPAC name becomes 5 tertiary butyl 3 ethyl nonane. Or this group name can also be written as 1, 1 dimethyl ethyl. 1, 1, this is a first carbon, this is a second carbon. There are two methyl groups on a first carbon. Therefore, it is 1, 1 dimethyl ethyl, and this substituent is ethyl. To compare their preference in alphabetical order, here the name of the substituent itself dimethyl ethyl. It doesn't mean that methyl ethyl is present two times. Therefore, the D must be considered to write alphabetical order of the substituents. D comes first, then E. Therefore, the substituent name dimethyl ethyl comes earlier than the ethyl substituent. Other IUPAC name can also be written as ethyl or methyl propane 2YL. Here E comes earlier than M, therefore its IUPAC name becomes 3 ethyl 5 2 methyl propane 2YL